Now we want to switch to a different type of image. These are electron photomicrographs. Electron photomicrographs have more detail, which allows us to see smaller and detailed things, but you have to start learning what they look like. If you look at the key at the bottom, Nu is the nucleus, E is euchromatin, genetic material, and heterochromatin, genetic material in another form. Toward the top left is M, mitochondria, and in the top right, RER is rough endoplasmic reticulum. That's membrane that has ribosomes on it. Remember, ribosomes take messenger RNA and use it to make proteins. The G in the top center and a bit to the left is a Golgi complex, an area where proteins and other molecules are modified and put in vesicles to be moved around the cell. In an electron photomicrograph, continuous thin lines are usually a cell membrane and also the membrane around organelles. The top arrow of my 3 blue arrows points to a plasma membrane of rough endoplasmic reticulum. The middle arrow points to the nuclear membrane. Bottom arrow points to a membrane around the mitochondrion. Vesicles of the Golgi body are each surrounded by a plasma membrane or a lipid membrane, and the outside of the cell has a plasma membrane. So some questions. First, what's the diameter of the cell? Second, what's the width of a typical mitochondrion? Third, what's the thickness of the space inside the rough endoplasmic reticulum? That's the gray space in between the lines with the speckles on them. What's the diameter of the cell? Remember steps 1 to 4. Step 1, there are 2 things in here that are on the bacterial ruler, a cell and a lipid membrane. Step 2, the cell is about 10 microns. The plasma membrane is about 10 nanometers. Step 3, we already have an answer. The cell is about 10 microns. Step 4, check your work. It's hard to use the width of the plasma membrane to check here. It's so thin that it would be really difficult to add them up enough times to get to 10 microns. So the answer is about 10 microns, and we haven't been able to check. What's the width of a typical mitochondrion? Step 1, the whole cell, about 10 microns, and the plasma membrane, about 10 nanometers. The mitochondrion is closer in size to the whole cell, which is about 10 microns. These mitochondria, step 3, seem to be more than 1/20th the width of the cell, but not as big as 1/10 the width of the cell. So 1/10 times 10 microns is about 1 micron, or 1/20th times 10 microns is about 0.5 microns. So the answer would be about 500 nanometers to 1 micron. Check your work. If we remember that mitochondria were evolutionarily bacteria, and that a typical bacterium, E. coli, is about 1 to 2 microns, that would tell us that 500 nanometers to 1 micron is a reasonable estimate for mitochondria. Question 3 for this image, what's the thickness of the space inside the rough endoplasmic reticulum, the gray space that I pointed to with the arrow? Step 1, again, you have the cell and the plasma membrane. This time, the plasma membrane, thickness about 10 nanometers, is closer in size to the space than is the whole cell. The gray in the middle varies in different parts of the rough endoplasmic reticulum, but it looks like it's about 1 to 5 times the thickness of the plasma membrane, all the little black lines. So 10 nanometers times 1 would be 10 nanometers. 10 nanometers times 5 would be 50 nanometers. So the answer is probably somewhere around 25 nanometers, could be in some places as low as 10, and in other places as high as 50. Here we can actually check. How close were we? I've inserted a blown up image of a mitochondrion and some rough endoplasmic reticulum here. There's a scale bar in the bottom right where my arrow points. It's hard to see, so I've made it easier to read. I've made another scale bar, the thick blue line right beneath it, and if you can't read it, it says 0.4 microns. I made a second scale bar, 1/4 as long, short blue bar. 1/4 of 0.4 microns would be 1/4 of 400 nanometers equals 100 nanometers. So the short bar is about 100 nanometers. So how close were we? The answer for the inside space of the rough endoplasmic reticulum we got was about 25 nanometers. We were quite close, according to the scale bar. And the mitochondrions about 1 micron wide in this image, according to the scale bar. And again, we were quite close. Now go on to watch the next video or practice more problems on your own.